Okay, so we left off yesterday dealing with percents. We talked about converting percents to fractions, fractional form. I should be careful on my vocabulary there. Remember, it's technically not a fraction, it's a ratio. Or converting a percent into that decimal form, which is actually a rate, and then going the other direction. And then we talked a little bit about benchmarks for calculating percents as well. Well, today we want to get into the actual calculation, the exact calculation of percents, rather than having to use those benchmarks to build those percents. Now we're going to look at two different methods of calculating with percents. What I'm going to do is I'm going to cut my screen in half here. I'm going to use just the left half right now, and I'm going to talk about the proportion method. Proportion method of calculating with percents is based off of that proportion we used for converting fractions into percents yesterday. Notice I'm leaving the right-hand side of my screen blank. I'm going to come back and redo these same problems with a different method in just a little bit. So we might be asked to find
Recording is on.
65%.
65%.
Oops, somebody's microphone got clicked on. If you want to make sure you're muted. Thanks. Find 65% of 40. So where we're going to start with all these, because we know it's a ratio and we know we can set it up as a ratio, is with the percent, the 65%. That is 65 out of 100 as a ratio. Now, before we go about setting up the rest of this proportion, let's look at those pieces of this ratio first. First, the 100. Remember we said yesterday 100% is the whole thing, or the starting amount. It's what we referred to as the base amount. So it's the reference point. It's what every other part of our calculation is based off of. It's what all your calculations are out of. The 65 on top then is what is referred to as the portion of interest. It is a piece that is determined by that base amount. Now, it could be usually smaller than the base amount, but sometimes larger than the base amount. But the size of it is determined by that base amount and our percent. So now on the other side of this proportion, we're going to put another ratio, but this ratio is going to involve the numbers in the problem. There are always going to be two other numbers. Usually one of them will be the number missing. We're asked to find something here, so that's going to be one of them. Then we have the 40. But if we look at the wording here, it says of 40, and we can read that as out of 40, implies the 40 goes on bottom, because whatever we're looking to find, it's out of 40. Now this goes back to our proportions from yesterday. To solve a proportion, we're going to find the two numbers that are diagonal with each other. In this case, that's the 65 and the 40. And we're going to multiply those two numbers. 40 times 65 is 2,600. And then we have the number that is diagonal with our missing number. In this case, that's the 100. We're going to divide by that. Divided by 100 gives us 26 here. So 26 is 65% of 40. You might have blank is 120% of 35. So when we look at that one, again, we start with the percent. 120% is 120 per 100. Now we'll notice that 120 is larger than the 100. So here's a case where our portion of interest is going to be larger than our base amount. We have blank is 120. That kind of implies that that missing number goes with the 120. Of 35, again, you can read that as out of 35, implies that 35 goes on bottom. Once again, we're going to cross multiply and divide. So we find the two numbers that are diagonal with each other. That's the 120 and the 35. That's going to give us 4,200. And we divide by the number that's diagonal with our missing number, which is going to be the 100. Dividing by 100 gives us 42. So 42 is 120% of 35. Now, those first two wordings were slightly different, but very, very similar. I can word it quite different. I might say 70% of 60 is blank. We're going to start at the same spot. We're going to start with the percent. 70% is 70 out of 100. Of 60, well, again, we can read that as out of 60, which implies the 60 goes on bottom. So that would mean our missing number goes on top. Once again, we're going to cross multiply and divide. We find the two numbers that are diagonal. That's the 70 and 60. That multiplies to be 4,200. And we divide by the 100, which is diagonal with our missing number. 4,200 divided by 100 is 42. So 70% of 60 is 42. Well, let's look at some percent problems in a little bit different form. We might have something like 27 is 90% of blank. So again, we're going to start with that percent. 90% is 90 out of 100. 27 is 90%. That implies the 27 goes with the 90. And we can read this of blank. We can read it as out of blank. Implies that missing number goes on bottom. So now that's telling us, well, we've got the numbers in there. We can go ahead and cross multiply and divide. Now they're in a different spot. The missing number's in a different location. But it's still going to be cross multiply and divide. We find the two numbers that are diagonal. In this case, it's the 100 and the 27. 100 times 27 is 2,700. So we multiplied those two. Now the number that's diagonal with our missing number is the 90. So we're going to divide by the 90, giving us 30. 27 is 90% of 30. We have 25% of blank is 17. Well, again, we start with the percent. 25% is 25 out of 100. Of blank, if you read that as out of blank, that implies the missing number goes on bottom. So the 17 must go on top. Now again, we have one number missing. We have all the other three. We can cross multiply and divide to find the missing number. We find the two numbers that are diagonal, in this case the 100 and the 17, and we multiply them. 100 times 17 is 1,700. The number that's diagonal with the missing number in this case is the 25. We're going to divide by that. Always divide by the number that's diagonal with the missing number. So we divide by 25, and what does that give us? 68, I believe. 25% of 68 is 17. I have 42 is blank percent of 70. Now, I've been telling you to always start with the percent. Unfortunately, here, we don't have the percent. If we don't have the percent, it doesn't matter. We're still going to start with it. Blank percent is just blank out of 100. That means that this number, the number out of 100, is the one we're going to be looking for in this calculation. 42 is blank percent. That implies the 42 goes with that missing percent, so it goes on top. Of 70, again, we can read that as out of 70, implies that 70 goes on bottom. And once again, it's cross multiply and divide. We have three of the numbers, and we're missing one, so we find the two numbers that are diagonal, the 100 and the 42, and we will multiply those. get 4,200, and we'll divide by the missing number, the 70, gives us 60. So that's 60 out of 100, or 60%. 42 is 60% of 70. We might have blank percent of 120 is 48. Once again, we're missing the percent, so we start with just blank out of 100. So we know that that percent is the number we're going to be missing, the number out of 100. Of 120, again, you read that as out of 120, implies that 120 goes on the bottom in our other proportion, our other ratio. The 48 then will have to go on top. Once again, we cross multiply and divide. The two numbers that are diagonal are the 100 and the 48. We multiply those, you get 4,800. The number that's by itself is the 120. It's diagonal with our missing number, so we divide by 120. You get 40. 40 out of 100, or 40% of 120 is 48. So that is the proportion method. I like the proportion method for a lot of reasons. The main one is the calculation is always the same. The missing part might be in a different spot, but it's always cross multiply. Multiply the two numbers that are diagonal, and then divide by the other one. So it's always the same calculation. All you have to do is get the numbers in the correct spot in that proportion. When we do word problems coming up here in a few minutes, the words, the subjects of the word problem actually help us set up that proportion, because the numbers that are in the same spot of the proportion have to describe the same thing. So that proportion makes it easy to work with some of our word problems as well. Well, I promised you we'd come back and redo all of these problems with another method. And that method is going to be called the rate method of percents. The rate method involves convert the percent to a rate. So that's the first thing, is if we have the percent, we convert it to a rate. In this first problem, we have the 65%. Remember, the rate is just the decimal form, so 65% as a rate is 0.65. The next steps depend on the information we're given and what we're asked to find. If we are given the base amount, then the portion, I'm just going to write portion, that portion of interest is equal to the base amount times our rate. So here we have that base amount is what's given, the 40, times the rate of 0.65, and we get 26 as our answer, which is what we had up here. The second problem, we have, forgot my percent sign here, 120%. So 120% as a rate. Remember, we're just converting it to a decimal to make it a rate. Move the decimal over 2 spots, that becomes 1.2 as a rate. Once again, the 35 that we're given is that base amount. So we take that base amount times our rate. 35 times 1.2 is 42, which is the answer we had over here. For the third problem, we have the rate of 70%. 70% turned into a rate is 0.70, or just 0.7. And we have the base amount here of 60. 60 times 0.7 is 42. Now, for those first three examples, you might be looking at that rate method thinking, that looks a lot easier. Why don't we just do it that way? That one's a lot less work. You move the decimal point, you multiply, you're done. You don't have to set up the proportion. And that is true. I mean, the proportion method, it works best if you have a paper to write it down on to set it up. so that you can see which numbers you multiply and which one you divide by. The rate method's a little quicker in this case for these first three problems, because what we were given the percent, which we could use to find the rate, and we were given the base amount. And that's what the rate method has its place. It's used a lot when that is the case, where we have that base amount and the percent that we can convert into a rate, and we're just looking for that portion of interest. When we have a different setup, like this next problem, well, we still have the percent, 90%, which as a rate is going to be 0.9. But this time we are given that portion of interest. To find the base amount, we're going to take the portion divided by the rate. So here we were given the portion of 27. We divide by the rate of 0.9, which gives us 30. Same answer we had over here. The next example here, 25% is our percent. As a rate, that is 0.25. And once again, we're given that portion, the 17. So we do 17 divided by the rate of 0.25, and that'll give us 68. So you can see here, if we're going to try to use the rate method, we have to convert to that decimal form, convert to the rate, and then we have to figure out, do we have to multiply by that rate or do we have to divide by that rate? And there's even a third variation here for the last couple problems. Here we are given both the portion and the base. In that case, the rate is found by doing the portion divided by the base. So here our portion is the 42, divided by the base is 70. That's 0.6. And of course, we can convert that into a percent from a rate. 0.6 is the rate, the percent would be 60%. And for the last one here, we're given the portion of 48, the base of 120. We divide that out, you get 0.4. 0.4 as a rate, of course, corresponds to a percent of 40. So you can see here that rate method is quicker in all cases. Just a quick division or multiplication, as long as you can move the decimal point to convert between the percent and the rate, as long as you can do that in your head, it's a quick method. But you have to decide, do I multiply by the rate? Do I divide by the rate? Or do I divide two numbers to get the rate when using that method? So it's a little trickier. I find people make a lot fewer mistakes using the proportion method over here, just because things line up, especially when we get into word problems. Let's say I have FML Corporation estimates weekly profit %8 of weekly sales. Find the sales for a week when profit is estimated at $43,456 for the week. Just like with our other problems, we're going to start with a percent. We got 8%, so let's write that down. But remember that 100 is a base amount. That's the amount that the other amounts are derived from. They're based off of. 8 is the portion of interest. Now, in this case, what does the 8% represent? Well, profit is 8% of weekly sales. The 8 represents the profit. The 100 represents what that's based off of. Well, it's of weekly sales. So the 100 represents sales. So when I go to set up the other side of this proportion, if I put a number up here, it has to represent profits. If I put a number down here, it has to represent sales. So we look for the other number in the problem, which is the 43,456. That represents profit, the estimate of profit. And that's 43,456. So really, there's not a lot. You don't have to memorize the form of the proportion here. You just have to match up things that represent the same thing, that describe the same thing. So now we'll go ahead and solve this by cross multiplying and dividing. 100 times 43,456 divided by 8. Gives us $543,200 in weekly sales. So to get an estimate for the week of $43,456 in profits, we had to have $543,200 in sales for that week. Let's say Sam receives a raise from $16.50 per hour to $16.83 per hour. What was the percent raise? So this is kind of a tricky one because the number that represents our percent is missing. That's what we're trying to find. So it's blank out of 100. But we know that whatever that is, that represents the raise. And whenever we have a change problem like this, where we're changing from one number to another, the base amount is always the starting amount. It's what we started with. So in this case, the starting amount is the 1650. Now the 1683 does not go above it here because the 1683 does not represent the raise. It represents the new wage. So to find that amount, we're going to have to do a little work. 1683 is the new wage. We're going to subtract 1650 is the old wage. That's 33 cents. That's what goes in here. That is the amount of the raise. And now we'll find our missing number, our percent, by cross multiplying and dividing. 100 times 0.33 divided by 16.50. We get 2 here. That's 2 out of 100, or 2% raise. Which isn't terrible. I mean, a lot of years, they would have said a 2% raise is kind of insulting. But the last 5 or 6 years, inflation, the consumer price index increase has really been less than 1%. So a 2% raise is keeping with inflation and beating it a little bit. So it's not a great raise, but it's not a terrible one either. So we mentioned the idea of a percent change problem. Here we went from 1650 to 1683. We had to focus on the amount of the change. And those percent change problems are the ones where we make a lot of our mistakes. And there are 2 types of percent change problems. One is a percent increase. In a percent increase problem, we start out with a starting value. call the starting amount. We add some sort of an increase to it, get an ending amount. Looking at the previous example, the starting amount was 100%. That was the $16.50. There's a percent increase. That was 2% in this case. That was the 33 cents that we found. The ending amount would have been thought of as 102%. That would have been the $16.83. If we had put 1683 in here and cross multiplied and divided, we would have got 102. 102% in this case is not an incorrect amount. It's just representing something other than what we're looking for. The 102% was representing the amount, the ending amount after the raise. Let's say a shirt is marked $15, but is on the 40% discount rack. So this would represent the opposite of a percent increase. This is a percent decrease problem. In a percent decrease problem, we have a starting amount. But instead of adding an increase here, we are subtracting a decrease to get an ending amount. Once again, we have the percent. The starting amount is 100%. Here's a 40% discount. So we're subtracting as a decrease of 40%. If I subtract that 40%, the ending amount, 100 minus 40, is 60%. So if I look at the dollar amount, it works out the same way. It's $15 over here. The decrease would be 40%. 40 over 100 equals blank over 15. If we cross multiply and divide, 40 times 15 divided by 100 is 6. The decrease here would be $6. We subtract, the ending amount would be $9. Well, here, instead of finding the 40% and then having to subtract, we could have just found 60% right away. 60% of $15, if I cross multiply and divide, would be $9. So whenever we're dealing with a percent change problem, whether it's a percent increase like this one or a percent decrease like this one, every item in the problem is described by two numbers. One of them is a percent, and in these problems, both of the other one is a dollars. So here the starting amount is described as 100%, but it's also described as $16.50. The increase is described as 2%, but also as 33 cents. The ending amount was 102%, or $16 and, oops, my numbers disappeared there, 83 cents. Down here, same type of thing. The starting amount, described as a percent, is 100%. In dollars, it was the $15. The decrease was 40%, or $6. And the ending amount was 60%, or $9. We need to keep that in mind because whatever we put in our proportion, notice this 60% was with the $9 because they're from the same row of that table. The 100 went with the 15 because they were from the same row of that table. Whatever goes in our proportion has to line up in that table. Let's say that after a 20% discount, Pat pays $184 for supplies. what was the listed price? Now, listed price, or list price as it's often called, is the price that the object is marked. That would be before the discount. So here we have the list price, or the starting amount. We're going to subtract that discount to get the ending amount, or the amount paid. And as we mentioned in the last examples, each of these numbers or items is described by two numbers. One is the percent, and again, the other one here will be dollars. 20% is the discount, so that goes on the percent side for the discount. 184 is after the discount, so that's the amount paid. And it looks like those are the only two numbers we have, but there is always that lurking 100%, that base amount. And in this problem, the base amount is the list price. Remember, we said that base amount is usually the starting amount. And now we can find the percent for the amount paid because the numbers have to add up, or in this case, they have to subtract. 100 minus 20 is 80. The amount paid is 80%. We're looking for the list price, so we're looking for this number here. So what we put in our proportion has to line up in this table. So we need two rows off this table. One row will be the row that has both numbers, the percent and the dollar amount. In this case, that's the amount paid. The other row will be the item that has what we're looking for. That's the list price. Doesn't matter which one goes on top or bottom in our proportion. I'm just going to write them as they look here. So we have 100 and the missing dollar amount on top. On bottom, we have 80 and the $184. So 80 for the percent, $184. Notice we just took those numbers right out of the table. In fact, we could have just crossed out the middle row here and cross multiplied and divided right in the table if we wanted to. So now we cross multiply and divide. 100 times 184 divided by 80 gives us, oops, what did I miss there? I missed that. It's 230 is what that should be. $230. So that list price before discount was $230. Kim, let's do this. Let's say after Kim includes a 12% handling fee. The total charge is $504. How much was the handling fee? So, again, I'm going to set this up. We have the starting amount. I don't have a real word here, so I'm just going to put a starting amount. The words you use in here really don't matter as long as you know what they represent. We're going to add that handling fee. Then we're going to get the amount paid again. Once again, each of these items is described by two numbers. We have a percent and, again, a dollar amount. The 12% is the handling fee, so that goes there. The total charge of $504 is the total amount paid. That goes on the dollar amount side for the amount paid. And once again, we know 100% is representing the starting amount. Now here, this is an increase. We add that handling fee. So 100 plus 12 means that the amount paid is 112% of that starting amount. So we have both numbers for that amount paid row. We have the percent and the dollar amount. So we know we're going to use that in our proportion. We have to figure out what is it that we're looking for. We're asked for how much was the handling fee. We're looking for the dollar amount of the handling fee here. So that is the second row we're using, is the handling fee. So we can set up our proportion. Again, I'm just going to use the numbers just like they appear in the table. I've got 12 and a missing number for the handling fee. 112 and 504 for the amount paid. And I'll simply cross multiply and divide. I believe that gives me $450. Oops, not 450, sorry. $54. Let me double check that. 12 times 504 divided by 112, it is $54. So $54 was the handling fee. So when we have these decreases and increases, you have to be extremely careful to make sure you are aware of what the numbers are describing. I write out this table even when I'm doing them outside of class to help me keep track of things so I know where things go. There isn't a new quiz today. The new quiz won't be till Monday, but it's out there. It's posted in the week 4 folder if you want to get a head start on it. I think one person already has it done. The homework for today is 84 through 89, page 84 through 89. 1 through 53, the odds. Again, make sure you do some of the basic percent problems there. And then if you're feeling comfortable, jump up, make sure you do some of the word problems. Word problems, in my mind, are being able to take a written situation and pull out the information and do what you need to, do the calculations you need to, that's the key to math. That is the most difficult concept in math. And once you have that down, you've got math down. So make sure you're doing some of those word problems on each assignment. With that, that is all I have for new material for today. So I'll give you guys the last 12 minutes or so to get started on your homework.